My friends, welcome to this week's weekend special. So I was in a training for a couple of days, and in the hotel room I saw this doorstop, very interesting. So as you can see, you get into the hotel, lock the door, and manually um, turn this key on so intruders cannot get into your room when you are sleeping, because everybody has the key to your room theoretically in a hotel. I am really doubtful about the strength of this device, cause any impact I will definitely snap it off, at least right here, how it is all fitted in. But nevertheless, I liked it, and I think I will be modeling this. I gave a trial run here, and I built it in per design. As you can see, the justification for this model to try in per design was these countersink holes. When there are like holes like this, per design is really easy. Part workbench has just couple more steps to do things like this. So, and then I put these two parts together in assembly workbench, and then now it moves up and down just like it should be. So this week I will be building this model for you all as the special, and given how it is more on the assembly side of this, so I will be a little fast on the sketching and building the things like that. But if that becomes an issue or like preference for you, let me know. Maybe next week I'll change the pace. All right, let's go ahead and start a new FreeCAD document. I am using today the most recent one, the weekly build. So this was released couple days ago, 3 days ago, and hopefully the one version will come out pretty soon. With that, let's go ahead and create a body and a sketch. So I will start from XZ plane, and then let's go quickly with this basic sketch. I'm gonna go ahead and make this about 2 inches high, so about like 50, something like this, and then maybe 6 millimeter thick. And on the base I will make it about 30 millimeter width. Right, so that's my basic sketch. I want to extrude that both side. Say I want to make it symmetric to the plane, and I want to make it, I'll say about 2 inches, so that's 50 millimeter. Right, so we got that. So that is our base model. Let me go back and take a look at it. So I made this 6 millimeter. That will be one thing to remember later on. Now let's make these 3 holes. So I'll pick this plane and then draw a sketch on that plane. It will be simple. Three holes like this, just, and the diameter of these holes does not matter at this moment. All right, so now what I do is select this sketch and then come here with the hole, not the pocket. We talked about this in one of the previous videos. Pocket is a pocket and hole is a pocket with something extra. So we'll go there and say profile. For now I'm going to go ahead and metric regular profile and say it's a 4 millimeter standard hole, just like that. So far that is pocket, right? And we want to do some extra, that is the countersinking. So in the hole cut type I'm going to say countersink, and then in the depth side I'm going to say I want to push it down about 1.5 millimeter. And here one thing to take a look at it, this edge, my target is not to cross this line, so you may have to go update these based on how this countersinking looks. and that is good enough for now. And so we got that part taken care of. Now the middle one, there will be multiple iterations involved, so let's go ahead, start work on it. And I want to draw on this XZ plane, turn on the section view, and here I want to say I want to take this edge and this edge as my references. And then, so what I want to do, I want to do a half cut somewhere here. So I want to cut about half of what I had. So this was 6 millimeter. I want to say this, I want to make it about 2.5 millimeter. Right, so that would be the flap that will come up and down, something like that. And then this height, so for now it is 45, right? Let's say flap height, right? And we'll have to come back to fix this. For now I'm going to go ahead and keep it 45, but make sure that it is marked out, because we'll have to come back to fix this. And this, I'm just going to go ahead and make it 45. And what else? So this is doesn't matter, let's say 1.5 millimeter. Right, so that's actually a material reduction, so we can actually keep it if we wanted to. All right, and then I want to keep this around the same there. So with that, let's go ahead and make a pocket symmetric. So the total length was 50. Let's say I want to make it 45. Let's see how it looks. Maybe 40. Now I want to make it a bit more, so 36. Yes, that makes more. That's what I'm looking into. All right, so that height that we will come back to update, this height is right here. So this is the sketch meet pocket, and here in the constraint, because we named it, it comes up here flap height. So if we make that 40, this thing goes down, and that's where the adjustment will be required later on. All right, and now let's go ahead and make a hole right here. So that will be another sketch on this plane, XZ plane, and turn on the section view. So this is going to be circular hole, something like this. Let's say diameter of 2.75. Now it's steel material supposed to be, so 2.75 is like a considerable amount of diameter for this. If it was a plastic material, we would have to make it a little thicker. And I want to make it a centered, so this works fine. Now that sketch, I want to make a pocket through all on both sides. So that is my first part, and which is I'm going to go ahead and say base body. And now let's go ahead and create another body. And so this is going to be say swing part. Right. And now we will be using few references from here. Now because it's a different body, in part design the references may not work. So what I want to do, I want to say this surface, select this surface and take a sub-object shape binder. So that actually brings in the reference in here. Now I can go ahead and hide this just for now. We have this. Let's do one quick test here. I want to say here on the constraint here I want to say 42. So I change a parameter in that body, the sub-object shape binder is also changing. So this is fully parametric, which is great. That's what we want. All right, now our main target is to build a swing, and that will be not on this surface, because remember that surface is off the center. We don't want to do that. We want to just build that sketch on standard XZ plane. Here I want to take a reference of this circle, and then maybe this line, and then start building that flap. So if it is at this point, we want to start just a little bit above, maybe come here and make an arc, something like this. Okay, so now I can see this line, so maybe I'll have to update the color. All right, we'll do that later. And then I need another arc, something like this. It will be a little off center. I'm going to keep a minimum clearance gap here, say 0.5 millimeter. Let's clean up few things. So this is going to be tangential, and everything else is tangential already. Right, that's a fully constrained sketch, and let's see where that leads us. We have that sketch right here, and I want to extrude that for, so I forgot how wide it was, 42, and symmetric to the plane. So that's too much. I want to keep it some clearance here. I'm gonna say 35. Yep. Yeah, I think that the original gap was 36, so 35 makes sense. All right, so let's hide this binder now and bring our original base body, and that's how it looks like. This is how it looks like. All right, we're almost there. Now let's hide that back again, bring the binder one more time back, and I see already one problem where this is a bit off center than what I want it to be. I think that's good because it will be getting into there. No, it's not good. So let's go back and update this. Maybe we make this 5 millimeter, and that doesn't work. Okay, delete that point, and just like that. So we make these two on the same vertical plane, right? And then I say the distance between these two is 1 millimeter. All right, so let's see how that looks like. And now we can, oh, what happened to the extrusion? That extrusion is gone. So that was symmetric to the plane, 35 millimeter wide there. And this is how it looks like for now. It looks good. All right, so one more thing. Now I'll have to do a hole right through here, right? And technically it should be just a tiny little hole in here and tiny little hole there, but I'll just, for my convenience, I'll make a through hole. So what I want to do, I want to draw another sketch in the middle, on this plane, right? And I want to take a look at this binder. So what I want to do, I want to go ahead and hide this pad and take reference of this, right? And now I'm still in the sketching mode. I can go take a circle equal to there. So these two holes will be very tight clearance, just a little bit wider, not smaller. I want to make that 2.8, just a little bit bigger. All right, now let's bring back the pad. The sketch is in the middle right there, so you can see in the middle, and I want to make a hole through all on the symmetric to the plane. So there, that's my pocket. Pretty cool. I think that is done. Now I want to create a pin, so that will be another body. And so I'm going to go ahead and bring the original base body back and hide this one. So take this surface and take another binder. We got this binder, right? And the binder is at this edge, and which is perfect. We want to keep it there, and on that binder, on this surface, I want to draw a sketch, and then do that same thing that we just did a minute ago. Take these two, make that equal, and that's the end of the sketch. And here, okay, let's bring our pocket back. So this sketch I want to extrude on both sides, right? So it will be 2 dimensions, and I want to match it on this surface, right? So that would be going to be length 1. I'm say it will be length 2. 7, yes. And then on this side, let's keep that, say, 5mm round figure. Keep it like that. So this is going to be press fit, so it will be inserted from this way, press fit. But this swing was, as far as I remember, just a tiny little bit oversized, so this swing will be moving freely. All right, so we just build this. I want to mirror it over on the other side, and I think that will be an issue because it's in part design. So let's not worry about that. I think this is going to be pin. All right, so now that's the end of our building. Remember, we'll have to come back to fix this edge later on. Maybe right now I can go ahead and actually make that a fillet. So make that active body and take that edge and make it a minimum fillet for now. We will just come back to fix it. So we have base body, we have the swing, and we have pin, which we will be using 2 times. And that's the end of modeling. Now let's go ahead and put all these 3 parts together in assembly workbench. So this assembly workbench is totally different from the current stable version 0.21. The 0.22, or like which will be FreeCAD 1 version, the assembly comes as a default. I believe on cell build this model, and then FreeCAD integrated it as a default workbench. So this is for 0.22 only, or like this is for future days only. Let's go ahead and create an assembly, make that active, and then we want to start adding things with this insert component. I on the keyboard. In the assembly, I'm not using any keyboard shortcuts. I need to learn this thing. So we have door protection, which is the one that I just built earlier, and because it is open in that window, it's showing up. We don't want to care on that. So this is the one that I want to add. I want to add the base body first, and it says, do you want to fix it? Yes, the first one is fixed. Actually, it's showing up pretty confused here. Let me hit OK and add these three, hide them. So this is hidden, right? So this is the one we just added, and let's go back to assembly and add the swing. No, I want to add the pin first. There, the pin showed up right there. We can adjust it, maybe move it somewhere here. All right, so we have one part grounded, right? The next part is going to be take this pin and fix it in here. As I said, it will be a press fit, so that's going to be a fixed joint. So take the fixed joint, and the first I want to select the grounded part, and then second I want to select the moving part, and it fits in perfect, and we don't need any offset or rotation. Perfect. And so that's one pin. I want to use that same pin on this side, so let's go ahead, add that pin one more time. So this is right here, and maybe I want to flip it around, right, and bring it in here somewhere. All right, so let's take care of that. So we will create another fixed. So first I want to select this, so see how this axis moves, things like that. So the middle axis, the z-axis, is pointing outward. Maybe I want to keep it like that. Yep, so I want to match these two, otherwise it may not work. All right, so we have that part taken care of, and now I want to go ahead add the third part, which is the swing. Right, let's take it out, and now the swing will be moving up and down, centering these two pins. So what I want to do, I want to select this surface, and that surface, make it a revolute joint, right? And I can do that easily. So right here, that offset thing will play a role. I select this surface and select this surface and create a revolute joint, and I see how this is matching the center. So we will have to say, let's try this one. Yeah, it doesn't change much, so let's go back. Yep, that's the right way. And now I want to offset it. I think that was 36, was it? So I want to offset it 18. We are pretty close, bit more. That's too much. So 19. Yeah, looks like it's in the middle. And I'm gonna say, so I will come back to this minimum and maximum angle in a minute. For now, and because it's a revolute joint, and I'm just gonna go ahead and say that one is enough. So we just hooked it up with this, and there is no, we didn't do anything on here, and in my mind I think that's enough. So let's hide this. So now we have the assembly done. I can rotate it all the way around. You see the problem? It's going all the way around, but in reality it should stop right here, right? So that's where it should rest, and this is where it should come up. So this is the maximum, this is the minimum. We can fix that with the angle, but the maximum should be a forced maximum on this surface. What I mean by that is it should come up. So let's go ahead and take care of that. On the revolute joint, we want to say minimum angle 90 and maximum angle 180. It took me a few trial and error, but this works. So the swing starts from here and comes up all the way there. And now what I was talking about earlier. So as you can see, this is a gap, but what's supposed to do is this flap should go up there and then stop these. So that was the design principle, and that's why we made this eccentric. So what I have to do, I'll have to make this up a little bit. So that is going to be in the base body, and I think this is the sketch. In constraint, let's make that 45, and that's a little too much, but let's see how that plays. So now it should be free moving, and that's where it make the touch. So we maybe made it a bit too much. 44, it's touching now. Okay, perfect, we got lucky there. So as you can see, now it is free moving, and now it comes up at the 90-degree angle at the maximum. This edge touches this, so this is the eccentric part, and then it forces to stop right there. It touches there. That was the design philosophy, and that's why we made the change in the original base sketch. And I can spend few more minutes actually doing some filleting stuff like that, but that's not the point. Our main target was to build this model in the assembly and make sure that actually this thing touches there at the maximum limit, and then the minimum it stops, it flips right there. So this is the condition where you can open the door, and then this is the condition where the door comes from this way, stuck at this flap. So if you wanted to download this model or just take a look at it, I am going to upload this in my OnCell library, and I'm gonna do it real quick. So the address is lens.oncell.com. that's where you can go and then actually search for it. I will share the link in the description of this video. So I want to upload, and oh, look at that. Can I move it? You'll have to download this or like, and then actually take a look. So you can take a look at this model even in the browser without opening up in the, so this is the address of this link. In here I'm also building my 200 3D CAD models. I started uploading them one by one. I'll put those links in the video description as I go forward. But for this one, so it's right there. What I'll do, I'll just take this link, copy this, paste it in the video description of this video. Anyway, hopefully you enjoyed this process, and thank you for watching. If you have any question, comment or suggestion on this model building or the assembly workbench or anything else related to FreeCAD, please let them know in the comment section of this video. Thank you for watching. I will see you next time.